Hello. We are live. Okay. If you are joining, say hi. Please come up. The class is about to begin. Hello. 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 Hi. Please, as you're joining, please your name. As you're joining, your name on the comment section. As you're joining, your name at the comment section. Good. Please join. Let's start. You are welcome. Let's wait for the rest. You are welcome. Please use the link to join. You are welcome. Hello. You are welcome. Please use the link to join. You are welcome. So, cartography is the intersection of art, science, and technology. So, cartography is as old as mankind. Please join. We are waiting. Join. Let's begin. You are welcome. You are welcome. We are welcome. Join. You are welcome. This is Intelligent Map Lab. You are welcome. Please join. The time is fast spent. Yeah. You're welcome. We are still waiting for the rest. We are still waiting. We are still waiting for the rest to join. Please, your matric number at the comment section. Good. Okay. Thanks for joining. Hi. How you doing? You're welcome. Hi. You're welcome. Okay. All right. Please, as you're joining, your name. Okay. So let's start. As I said earlier, this is Intelligent Map Lab. We are going to look at digital cartography. And before we dive into that, what is cartography? You're welcome. So what is cartography? Cartography, according to Ellen, is art, science, and technology of making maps. Together with it as a scientific document and work of art. I repeat again, cartography is art, science, and technology of making maps. Together with it as a scientific document and work of art. Okay, now cartography is a discipline that involves or that intersects, you know what we mean by intersect or intersection, okay? That intersects art, science, okay? Okay, all right. Sorry for the network issue. So if you are talking about art, that is cartography. If you are talking about science, that is cartography. If you are talking about technology, that is cartography, okay? Now, we are digital cartography. The concept of digital cartography, the concept of digital cartography, we are talking of digital. The concept of digital cartography is the map projection, okay? Map projection, scale, symbology. Are we together? If you're hearing me, say we are with you. If you're hearing me, say we are with you. Type it at the comment section so I will know that you are getting me. Okay, so I said the concept of cartography lies with map projection, map scale, symbology, and the likes. Okay, that is the concept. Now, if you are talking of map projection, you know, the art feature cannot be, you know, the feature of the art, the roads, the building, the rivers, and the likes, they are on a curved surface, right? They are on the curved surface. So for you to get that, as you're mapping, for you to get that feature from this curved surface to plain surface, which could be your phone, the paper, or your laptop. So you have to project it. Sorry for the noise at the background. So you have to project that picture to a flat surface. Okay, let me use this word. So you have to draw that picture from a curved surface to a what? To a flat surface. Reason why we use projection, so that the shape of that picture, maybe building, road, river, will be maintained. The distance will be maintained. The size will be maintained. So that is why there is need for projection when you are mapping. It's very, very important. We don't just map, because if there is no projection, you can't call it a map. It is what? It is a figure. Okay? It is a figure. So what do? We use projection to project that building you're mapping, to project the road, to project in short, the street, whatsoever. So we use projection. So it's a very fundamental concept in cartography. Then the next concept in cartography is the scale. You know, you cannot you cannot put this building, okay, for instance, we are said, you cannot put this building just as it is on a flat surface. There's no way that can be done. You cannot put it just as it is on a flat surface. So it needs its reduction. So that reduction is done by what? By the use of scale. So you have to reduce this building so it can be fit properly to what? To the flat surface. As I said earlier, the flat surface could be what? Your phone, could be the paper, could be your screen, your laptop, your desktop. So that is the flat surface. So you have to reduce the building, the trees, the river to a reasonable size, so that it can be fitted on the flat surface. Don't forget, as I do say, that location is critical. You don't need to compromise with the location at all. Don't compromise with the location of anything you're drawing. Any map picture you're mapping, the location must be there. Don't shift the location, okay? So that is that. So, and you all know the types of scale we have. We have the small scale map, the medium scale map, and the large scale map. Small scale map is a map that covers a very large area. It could be the continent of Africa, it could be the continent of Europe, it could be the continent of North America or South America or Caribbean or Nigeria. So that is a small scale map. It covers a very large area. Why it is called small? Because the feature on it, okay, the feature on it will be is small. The scale that allows that, the scale is small. So that's why it is called a small scale map. It covers a large area, and the feature on it, for instance, your building where you are living, if you are to map a small scale map, the building will just be like a point, because on that map, it is not only your building that will be there. There are many things, and it covers a large area. Good. Now, for medium scale map cover relatively large and small area. It's in between. Okay, that is, the feature on it will be a little bigger than the small scale map. Now, the large scale map cover a small area. Large scale map cover a small area. That means that the feature on the small scale map is big. The building is big, the roads are big, the rivers are big. That is, the graphics, the icon, the graphics are big. That is why it is called what? A small scale map. It covers a small area, and the graphics, the symbols are what? Big. Now, that is that about the concept. Then the third concept is what? Is symbology. No, you cannot do without symbol. Those three, if you are to represent it on the map, what will you use? You use symbol or you use icon. Okay, let me use icon, use symbol to represent that tree on the map. Okay, so that is why you need to do that. Use symbol, okay, to represent. If you for building, what do you use? You draw a square, or depending on the shape of the building, could be a square, could be a rectangle, it could be a building half corner, or it could be a round cycle in terms of hot. Okay, so that is what? That is about what? Symbol. Now, the fourth concept on cartography is generalization. My dear, you cannot map feature without generalizing it. You have to generalize it, because now, if for instance you have to map schools in a particular area, quite all right, the symbol or the data you will get, it will be what? It will be, let's say, road, yes, unnecessary road, residential building, the schools, maybe rivers. So you gather all those data. Now, for you to come and put it on the map, you have to generalize it. Why? Because the aim of that map is schools. So not all the buildings on that area of study that you should include that should be included on the map. Not all the buildings. So you have to select, because the aim of the map is to show schools in that study area. So you just select few school buildings. All the schools in that study area have to be there on that map. So you have to select few buildings like residential, or maybe residential and commercial buildings. Then also you have to do what? Select roads. Roads are important. So that you have, when you have done with all that, you generalize it, okay, so that the aim of that map, which is what? Schools, will stand out. That is that about the concept of cartography. Number one, I made mention of map projection, concept of cartography, map projection, scale of the map, symbology, and what? And generalization. Those four things: map projection, scale, symbology, and what? And generalization. Those are the concepts of map cartography. Now, concept for GIS, for Geographic Information System, the concept is what? One, spatial data. Spatial data. The building is a spatial data. The tree you pick is a spatial data. What we mean by spatial data, because it has location, it has coordinates, X, Y, Z coordinates. It has location, maybe longitude 3 degree, 4 minutes, 20 seconds, latitude 2 degree, 1 minute, 30 seconds. That is the coordinate. Or he said in the it has 4, 6, 3, 8 Eastern, 6, 4, 5, for instance, 6, 4, 5, 7 Northings. That's the location. That is the position. Are you getting me? That is the position of that fixture. So that is why it is called spatial data. Spatial data meaning it has what? Position on the space. Where you are now, where you are listening to me, you are on a space. You're occupying a position right now where you are in your bed. It could be in the class, it could be on the road, it could be in the house. Where you are right now, that is the position you are occupying. So at that moment, you're occupying a coordinate. You have a coordinate, the location of you. Are you getting me? So that is spatial data. That is one of the concepts in GIS, spatial data. Another concept in GIS is what? Attribute data. Attribute data. Okay, you pick the spatial data, which is the position, the coordinate. Now the attribute data, you tell me, okay, this house is, for instance, this house is white. The color of the house is white. The building, the roof is green. So that is the attribute. You are telling me, you're giving me information about the building. Okay, this road, there is a road here. The road is what? The road is tarred. The road is not tarred. The road is wide. The road is not wide. That is the attribute of that spatial data. The road is a spatial data because it's occupying a space. Now, the attribute of that data is the description. You are telling me that the road is a tarred road. The road is on tarred road. The road is wide. The road is small. That is what? That is the attribute. Now, when you are carrying out your project, when you are doing map, you not only limited to your what, to your school project, as a mapper, as a photogrammetrist, as a cartographer, any spatial data you pick, get the attribute data. Any spatial data you pick, get the attribute data. Okay, so that is the concept. Number 2 concept for GIS. The first one I mentioned, spatial data. The second one is attribute data. Then the third one is what? Is hardware and software. You use what? The hardware, which is your laptop. Your phone now you are using to come up to this class, to link up with this class, is the hardware. Okay, so that is the hardware. The link you use, let me use that word, let me so you understand. The link you use to join this class is, I would consider it to be the software. Okay, so the hardware it could be the what? The scanner, the printer, the hand GPS, and many more. Okay, those are the hardware. Now the software, the GIS, the ArcGIS, the QGIS, the SOFA, the Idrisi, and many more. Okay, the software you use to do what? To map the spatial and the attribute data. Okay, so that is the third concept in GIS. Then the fourth concept is what? Is people, you and I. The another analysts, the people that analyze the result, as in that try to get the result of what you map, so that they can carry out meaningful decision, or to carry out projects you map. So the decision maker pick that to carry out what? to make decision. For instance, if you are to map this road, all the roads in your locality, and the chairman or the major or the governor happen to see the map, he will say, there are many roads in this county. There are many roads in this local government that doesn't have what? That the roads are not tarred, that the road is dusty. So what do? They carry out decision, they make decision out. Please, this road has to be tarred, or this road has to be upgraded so that all the potholes and the lights can be eliminated. So it's from your map that those decision maker will carry it out. You, the people, the person, makes the fourth concept of what? Of GIS. I hope you get me. Please, if you get me, type at the comment section that you are hearing me, so that I know that I'm not just talking to myself. Okay, so now I've mentioned one, spatial data. That is the concept of GIS. Spatial data, attribute data, hardware and software, and the people. That's there. For cartography, the concept is map projection, scale, symbology, and what? And generalization. So we are done with the concept of cartography and GIS. We have done with the concept and cartography and concept of cartography and GIS. That is that about that topic. So the last thing we are looking at now will be what? Sources of data for digital cartography. What are the sources of data for digital cartography? That's what we are looking at now. This is the last one. The sources of data for digital cartography emanated from, let me group it like this, emanated from remote sensing. Sources of data for digital cartography. What I mean by that, how you will sort, how you will get data to carry out your map, carry out your map in digital cartography. Students that are here, cartography students know that it will come from remote sensing. Then under that remote sensing, we have what we call LiDAR or LiDAR. I don't know how you pronounce it, LiDAR. Then also we have what we call aerial photographs. For the photogrammetries, aerial photograph. Under remote sensing, we have what? LiDAR or LiDAR, as you may call it. Then we have what? Aerial photographs or photogrammetry. Are you getting me? That's under remote sensing. Remote sensing is all about capturing data without having physical contact with the fixture. Capturing data without having physical contact with the fixture. That is that. Remote sensing, under remote sensing, you have aerial photograph or photogrammetry. Then LiDAR, that is that about that. Then we also have GNSS, Global Navigational Satellite System. GNSS, Global Navigational Satellite System. Now, your GPS, that is what it works with. Your GPS works with the Global Navigational Satellite System. So under GNSS, we have the word, the GPS. That is that about that. Now also we have the GPS, we have the land survey or field data. Okay. Then also for analog, or let me say existing, let's say cartography or existing map. Let's say cartography. I hope you understand what I mean. For cartography of now, under it, we have what? You have to scan the map. Most data that you use for mapping or for digital cartography, most mapper comes from what? Most mapper come from existing map or maps. So what do you do if you have existing map? You do what? Practical class, for those of you that were there, you georeference it, I asked you in that class, why do we georeference? We georeference so that the location on the map will correspond with the actual location on the curved surface, on the Earth surface. That's why we georeference. Those locations, those points, point features, those line features, those area features will correspond with the one on the real Earth surface. Okay, that is why we reference. That is, when you pick a coordinate using your GPS, what we just discussed, the GNSS. When you pick a coordinate of a tree, a coordinate of a road, a coordinate of a river, you pick the coordinate. Okay, that coordinate you pick there, if you are to check it with the already existing map that has that feature, so that coordinate you pick using your handheld GPS or whatsoever correspond with the map, the one that already mapped. Okay, that's why we have to georeference. Another thing why we have to georeference, so that the coordinates will not be misleading. Okay, that's why we have to georeference. So you scan the map, you georeference, you digitize. Okay, then the next one that we have is what we like call collecting of crowd source. Crowd, as in crowd, CROWD, then source. So crowd source. So it could be from OpenStreetMap. The OpenStreetMap. Okay, in the next practical class, I will carry you through that. So OpenStreetMap are crowdsourced that voluntarily contributed in mapping the mapping out the world topographical map, so you could get your source of data through OpenStreetMap. Okay, so and many more. So those are the crowdsourced. Okay, so for digital for sources for digital cartography, one, I make mention of remote sensing. And under remote sensing, we have the aerial photograph, we have the LiDAR. Then I made mention of GNSS, Global Navigational Satellite System. And under that, which we have our GPS. Okay, then we have existing map or cartography. And under that, what do we have? We have the analog or the paper map that you scan, you georeference, and you digitize it. Okay, that is the third. Then the fourth one is the crowd source. Okay, the crowd source. So any question? Any question? Any question? So please, if there's no question, we end it here. Okay, please, your matric number. Hi to every one of you that joined. Hi, I've seen you. Hi. So your matric number, let it be typed. Type it at the comment section. Your matric number. Please type it there. Please, next week on this same platform, we are going to have our test. Okay, next week Friday. Please, those that are not here, you are more than this. So those of you that are not yet, tell them next week. Okay, we are going to have tests on this same platform, using this same platform, YouTube. Then also the assessment will be test and practical. We are going to have two assessments done here. Then practical. Those of you, please, let's get ready when we get laptop. So you do two assessments for me. Okay, so I'll assess you with that. Please, Monday, for the Cato student, Monday, please, those of you that have laptop, come with it. We are going to have practical. We are going to have our practicals on Monday. So your matric number and your name at the comment section. So if you have any question, do you understand? Hi to everyone. Hi. So thanks for joining for that. We are going to end it here. You are 11 people are in this class. I don't know, you are more than this. I wonder why you are in 11. Okay, that's okay. Please, The attendance is going to be part of, for those of you, attendance, those of you, please put your matric number, because I'm going to use it as, it's going to serve as part of your assessment. And those of you that are in this class, I'm going to use it as so there's mark for those of you. You are just 11 of you. Please, I want to see, hey, thank you for your thumb up. Please, thumb up, thumb up. Thank you so much. Thank you. Please, more thumb up. 11 of you. I'm going to take your attendance. Okay? I'm going to take your attendance. I'm going to use it as I'm going to award marks for those of you that attended this class, because I don't know why I made it easy that on your bed you can join. Over there in abroad, that's what they do. On your bed, I make it easy. I can join this class on your bed. You don't need to come to class still, and you're something, and it's only how many I'm seeing here? 12. Please, your matric number. Please, all of you, give me a thumb up. Try that. Thumb up, thumb up, thumb up for me. Thank you, thank you. So yeah, 11. Okay. I had 12. I don't hope those are going that have opting out. Your matric number is there, right? Please, I'm going to award marks for the matric number. Good. 11. Okay. Please, I'm going to award marks. I have only 7 thumb up. Yeah, 12. Please, thumb up, thumb up. Thank you so much. It's not easy to talk, wake up and prepare for this class. So thumb up. Thank you. Thumb up more. Yeah, 11. So please, 12 of you. 12 of you. Others should not. I've taken note. I've taken note of those that are here. Good. I've taken note of those that are here. Please, your matric number. Please. So if you are done with your matric number, you can go out from the class. Go out from the class. You are done. This student can be so funny. So because I said I'm going to award marks, so I hope you are not telling others. Okay, I noted 12 of you. Okay, so thank you so much. See you in the next online class. That will be test next week Friday. Test next week Friday. Online here. Okay. All right. Bye. Cha cha. Cha cha. Thank you.